Okay, so this is the review packet number 2 for Unit 3, Structure of Matter. So you're going to need your periodic table and the review packet. So example 1 is lithium. So I know it's lithium because the atomic symbol is Li, and then I'm going to use my periodic table, and then right here I see lithium. So I can actually write that in. Lithium. So I have my element tile right here for lithium. The atomic number is 3, and the atomic number is the same number as protons. The mass is 6.94. Since it's 6.94, I'm going to round up to 7. Neutrons is protons has a positive charge, electrons has a negative charge. Neutrons equals the atomic mass minus the number of protons. So this minus this will equal neutrons. So that is going to equal 4. And the electrons. So I'm going to go over here. I don't have any charges, so it has to be neutral. So for the atom to be neutral, my protons need to equal my electrons. So this will have to be 3. Because there's no charge, it is neutral. For my period, this section is telling me I need to look at the periodic table. So period's going across, group is going down, and family is based on, the color code, right? So if we're going across first, it is in period 2, and it is in group 1. Now, on the test, you will not have a color-coded key, but you will now have like a color-coded periodic table without the key. Since it's group 1 and it's this orangey color, it is an alkali metal. Okay, let's practice the next problem. So I have Mg2+, and this one I can also show while moving. So since it's Mg, I know it's magnesium, and it's an ion because it has a charge. So the atomic number for magnesium is 12. The atomic mass is 24.3. So we will round down to 24. And the number of protons is the same as the atomic number. These two are always the same. The amount of neutrons it has is 12, because 12 plus 12 equals 24. Number of electrons. Now, this is tricky. So it's plus 2. There is a plus 2 charge. So, since it's positive, thinking about like our cat, so like positive, I know it's a cation. So if it's positively charged, that means it needs to have 2 more protons than it does electrons. So if this is 2+, we're actually subtracting 2 to our electrons. So there's only going to be 10 electrons. For magnesium, the period that it is, it's period 3, and it's group 2. So period 3, group 2, and this is our alkaline earth metal. Okay, so we have Cl negative. Cl is chlorine, which is 17. I'm sorry, there's kind of a glare on my periodic table. Maybe let me move it over. Okay, there. So I know that this is chlorine. Sorry, the spelling. Okay. The atomic number is 17. Remember, the atomic number is this top left corner. The atomic mass is 35.45, so it's going to stay at 35. And then my amount of protons is the atomic number. 35 minus 17 is 18. So it has 18 neutrons. It has a negative charge. So if it has a negative charge, I know that this is an anion. Now, since it doesn't have a number here, that means it's just 1. So then it will have one more electron than protons. So it has to be 18. Okay, so for my periods, I know it's the numbers going across, so this is 1, this is 2, then we have 3. So it's period 3, just like magnesium, and this is group 17. And it is a halogen. Okay. And E, so that is neon. It is right here. Its atomic number is 10. Its atomic mass is 20.1, so I'm going to round down. The number of protons it has is 10, and 10 plus 10 equals 20, so it has to have 10 neutrons. It is neutral, there is no charge, so that means it has to have an equal amount of protons as it does electrons. It is neutral, like I said, because we did not see a charge. And it is in period 1, 2. Oh, lead. Period 2 in group 18, and it is a noble gas. We are among nobility, so purple, purple, it's in that family. Okay, so we have aluminum plus 3, so we're right here. So aluminium, atomic number is 13. Its mass is 26.9, so we'll round up to 27. And its number of protons is 13. 13 plus 14 equals 27. It's plus 3, so that means it needs 3 more protons than electrons. So this will be 10. Because it has a positive charge, it's a cation, and its period is 1, 2, 3, and it's in group 13. So 3 down and across, and in group 13. And this is a post-transition metal. Post-transition metal. Okay, I'm going to fold this so we can see the rest of the answers. So we have, oh, this is not a good fold. We have Si, which is silicon. So Si, silicon, and oh, I forgot our order. That was probably a bad idea. So silicon, its atomic number is 14. Its mass is 28. It has 14 protons. 14 plus 14 equals 28, so the neutrons is 14. And it's neutral, so it has to have the same number of protons as electrons. And we'll just get our mega table back, because I think the heading is meaningful. So it is neutral. It is, if we're looking here, sorry. So, talking about silicon, It's in period 3 because we're going 3 rows down, and it is in group 14. So 3, 14, and it is in our diagonal family of metalloids. Okay, so let's do our next one, Fe. So we have iron. The atomic number, we'll just pull this when we need the family. So our atomic number is, or this is covering, so here, we'll do this. There we go. Our atomic number is 26. Our atomic mass for iron is 55.8, so we're going to round up to 56. So we have 26 protons because that's our atomic number. 26 plus 30 gives us 56, and there's no charge, so it has to have 26 electrons because this is neutral. For our period, oh, you can kind of see it. So it's in period 4, and then it is, I'll pull this down, but it is in group 8, going down. It is in our big transition metal family. So transition metal. Okay, so Br81. So what does this big number mean? This is telling us that it's an isotope of, you can kind of see the element over here, bromine. So we have bromine, and it's an isotope. So the atomic number is still 35. Bromine's normal atomic mass is 79.9, but this is an isotope of 81. So since it's an isotope, we write our new atomic mass. So this is giving us our new atomic mass. And the number of protons is still 35 because it has to equal the protons and atomic number. 35 plus 46 equals our new atomic mass because this is a isotope. So isotopes affect the number of neutrons. Since this is neutral, there's no charge in addition to the isotope. We have the same number of electrons as protons, so it has to be 35. It is neutral. And to find bromine, we need to go to period 4, and then this is group 17. So 4, 17, and we'll go halogen. Okay, so C14, we have another isotope. This time it is an isotope of carbon. So we have carbon 14. So carbon here. The atomic number is still going to be the same, 6. So our protons is still 6. Our atomic mass is now 14 instead of 12. So 14 minus 6 is 8. So we now have 8 neutrons instead of 6 with the normal atomic mass of 12. Since this is neutral, there's no charge in addition to the isotope. It has to have 6 electrons. And this is neutral again. And it is in period 2, group 14. So 2, 14, and this is in our green color, so it is a non-metal. Okay, and then our last one is U. So dun, dun, dun. So uranium, right here. So uranium, its atomic number is 92. The atomic mass is 238, right? 238. So the number of protons is 92. 92 plus 146 gets us to 38. So we have 146 neutrons. This is neutral, so we have the same number of protons as electrons. Neutral. And our period for uranium, because it's in the actinoids, is period 7. And then it would technically be in this, so these two bottom rows get inserted here, like these whole rows, so I'm just going to put 3 to 12, and it is, if we want to be official, it is an actinoid for this one. Okay, so that is the first page of the review packet complete. Thumbs up.